Dear students, Assalamu alaikum. My name is Waqar Ahmed. I am your physics teacher and I have to teach you equilibrium, its condition and states. Right, students? Please open your books. Equilibrium. What is equilibrium? Anyone of you knows what is equilibrium? Students, a body is said to be in equilibrium if no net force acts on it. Okay? When no net force acts on that body, then body will be in the state of equilibrium. Right, students? Here we have a very good example of this log. Here we observe that two forces F1 and F2 are acting upward, and whereas its weight is acting downward. These two forces F1 and F2 are balancing the weight, balancing its weight W. So no net force acting on it. Therefore, this log is in a state of equilibrium. Here we have a very good example of this hanging photograph. It is also in the state of equilibrium. Now we will discuss conditions for equilibrium. There are two conditions of equilibrium. One is first condition of equilibrium, another is second condition of equilibrium. What is first condition of equilibrium? Dear students, when no net force acts on that body, then body will be in the state of equilibrium. It means sum of all the forces acting on that body must be equal to 0. When there are number of forces F1, F2, F3 up to so on Fn are acting on that body, the sum of all the forces must be equal to 0. Therefore, F1 plus F2 plus F3 plus up to so on plus Fn is equal to 0. Here plus sign F1 plus F2 plus F3, these are denoted by summation sigma. So therefore we will denote this F1 plus F2 plus F3 plus up to so on plus Fn equal to sigma F. So sigma F is equal to 0. Right? It means sum of all the forces acting on the body must be equal to 0. Okay, dear students? The first condition for equilibrium can also be stated in terms of x and y components of the forces acting on that body. Therefore, sum of all the forces along x-axis, sum of all the forces along x-axis will be F1x plus F2x plus up to so on plus Fnx is equal to 0. So we can write it sigma Fx is equal to 0. Likewise, sum of all the forces acting along y-axis must be equal to 0. Sigma F is equal to 0. Right? Dear students, when sum of all the forces acting on that body is 0, then body will be in the state of equilibrium. This is the first condition of equilibrium. Now we will discuss the second condition of equilibrium. First condition for equilibrium does not ensure that a body is in equilibrium. Therefore, we have a need of the second condition. And here we can observe that when sum of all the turning effects acting on that body is 0, then body will be in the state of equilibrium. According to this condition, a body satisfies second condition for equilibrium when the resultant torque acting on it is 0. It is denoted by sigma tau is equal to 0. Dear students, you have to prepare this article in all respect. Here in example 4.6 we can observe that how this body is in the state of equilibrium. Okay, you have to solve this numerical by yourself by consulting your book. Okay, now we will discuss states of equilibrium. Dear students, there are three states of equilibrium. One is the stable equilibrium, another is the unstable equilibrium, and third one is the neutral state of equilibrium. Okay, what is stable equilibrium? Dear students, a body will be in the state of stable equilibrium when we disturb a body slightly its center of gravity rises, and after leaving the force, after leaving that body will again come back to its original state. This state, you can observe this in figure 4.33. Here a book is lying on the table. You can observe that initially, and when force applied on that body, on the book, its center of gravity rises, and when force is removed, then body comes back to its book, come back to its first position, its initial position. So we can say that this book is in the state of stable equilibrium. Okay, now we will discuss unstable equilibrium. Here this is a rostrum, there is a dice. When we apply a force, when we disturb this rostrum, we observe that its center of gravity lowers, and when we remove this force, this rostrum does not come back to its original position. So we can say that this is in the state of unstable equilibrium. Okay, you can observe it in the state of in this particular case, in case of 4.36, here is a very good example of pencil. When we apply a force, we observe that this pencil does not come back to its comes back to its original position. Its center of gravity lowers, and this pencil is in the state of unstable equilibrium. Dear students, but in this particular case, as mentioned in the figure, it is in the state of stable equilibrium. Here we are as already I have mentioned it to you, this is the case of unstable equilibrium. But students, it can be in the state of unstable equilibrium when its center of gravity lowers, when the center of gravity of the rostrum lowers, and it doesn't come back to its original position. We can say that it is in the state of unstable equilibrium. But here in this figure, as mentioned in 4.34a, it is in the state of stable equilibrium. 4.34b, it is also, and C, we observe that initially center of gravity rises, and when we remove the force, this rostrum comes back to its original position. So we can say that this is in the state of stable equilibrium. But in case of unstable equilibrium, we have a very good example of this pencil. We observe that when we apply a force on that pencil, its center of gravity lowers, and we observe that by removing the force, this pencil does not come back to its original position. So it is in the state of unstable equilibrium. Okay, now we will discuss neutral equilibrium. Dear students, here we can observe that there are two balls lying on this surface, on the smooth surface, on the horizontal surface, and we move this ball from one point to another point B. We can observe that the center of gravity